Hello, everybody. I hope everything is going well with you. This is my lecture for Friday, March 20, ME3011, Thermodynamics, Week 9, Session 3. So in the previous lecture, we discussed the details of steady flow devices such as turbine compressors, heat exchangers, diffusers, nozzles, mixing chambers, throttling valves, and pipes and ducts. Today we will go over the on a steady state, on a steady flow processes. So uh, for the unsteady flow processes, the first thing keep in your mind that most engineering equipment work under the steady state, conditions. We already discussed it. You can assume that all, turbines, compressors, diffusers, nozzles work under the steady state conditions. So the only case, actually, you should be a little bit careful, or devices that work under the steady state condition is a tank during discharging or charging process. So in these cases, the total energy and the total mass of control volume changes with time. Correct? For example, consider this tank. So this is during the charging. It's connected to this supply line, and then fluid is added to this control volume. So the total mass of this control volume plus the energy of this control volume changes with time. So this is not a steady state process, it's an steady state process. In this course, we actually discuss a specific type of unsteady flow processes, which is called uniform flow processes. For uniform flow processes, we assume that the thermophysical properties of fluid in the inlet and exit are constant or uniform or steady, but the total energy and total mass of control volume changes with time. So the shape and the size of control volume may change during the unsteady state, processes. For example, in this case, you can see that the total volume, is not constant. And for this case, we are dealing with a rigid tank with a constant, volume. Now, so to analyze on a steady flow processes, we need to develop new mass and energy balances. The energy and mass balance equations are totally different from those steady flow processes. For mass flow rate, you can start from the general equation for on a steady state processes. You can write sigma m dot in minus sigma m dot out equals to the dm control volume over dt. This is for the mass flow rate. Or you can write the mass balance equation. You can write m dot m in minus m out equals to the delta m of system. Or you can write m in to the control volume minus me equals to the m2 minus m1 for the control one. So the mass of control volume at state 2 minus a mass of control volume at state 1. So keep in your mind that we generally use this equation to analyze, the tank during charging and discharging processes. So this is the mass balance equation for unsteady state processes. For the energy balance, to develop energy balance for unsteady flow processes, you can start from this general equation. This is the energy balance equation. E in minus E out equals the delta E system. So if you remember, we already discussed that Q, heat, actually work, and flow work can cross the boundaries. So E in is a combination of Q, W in, and E actually mass in. E out is a combination of Q out, work out, and flow work out. So, and then the delta E for the system equals to the M2 times E2 minus M1 E1. If you add all these, items to this equation, you will reach to this, general equation. So E in is this term, E out is this term, and this term is the delta E for the system. If you remember from the previous section, theta is a combination of enthalpy, kinetic energy, and potential energy. And E is a combination of internal energy plus kinetic energy plus potential energy. So if you combine all these, terms for the theta and E into this equation, and then combine, these three terms, you will reach to this, equation. This is the energy balance equation for, on a steady flow processes. Q net minus W net plus sigma m times theta in minus sigma m theta out equals to the M2 E2 minus M1 E1 for the system. Keep in your mind that the Q net is Q in minus Q out, W net is W out minus W in, and then you have the definition for theta and E here. So these are, energy and mass balance equation for on a steady state processes. Now, as a summary of this chapter, because we done, chapter 5. So in this course, you can consider all these equipments, as steady flow devices. Nozzles, diffusers, turbine compressors, throttling valves, mixing chambers, heat exchanger, pipe, and ducts, work under the steady state condition. For unsteady flow devices, you are dealing with unsteady flow, processes whenever you have tank during charging or discharging processes. Okay, guys. Now, what I'm going to do, I'm going to solve two problems from this part, and then, yeah, we are done with chapter 5. Okay. So, example 1. We have a tank, and then this is the discharging process. We open the valve, and so we have some information for the for this process. Let's go over the problem, and then we can just discuss the detail. The first thing, guys, to study actually this type of problem, to solve this type of problems, you need to answer two questions. The first one, is it open or closed system? If this is closed system, you are dealing, with the mass and energy balance for a closed system. If this is an open system, you are dealing, with the equations for energy and mass balance equation for open system. So for sure, this is an open system, correct? There is an inlet, actually exit here. The second question is, if this is a steady flow process or unsteady flow process. So this is a tank during discharging process. So for sure, this is on a steady flow processes. So this is the two, questions. Now let's just, complete, the information for this part. So I just make this table. So this is a tank during discharging process. The fluid is R134A. So this is a rigid tank. The volume is constant. We have the volume, and then we have M1. This is the mass of control volume at state 1. It's 0.55 kilograms. It's a saturated mixture. This is really important. And then we have the T1, the initial temperature. And then we open the valve, and then the vapor, but not the liquid. So saturated vapor leave the control volume. And so the temperature is constant, T1 equals to the T2, and M2 is 0.15 kilograms. Now, you're asked to find the heat transfer necessary with the some Q. What's the Q net? Okay, to find the Q net, what you need to do, guys, you need to set the energy and mass balance equations. Let's start from the energy balance equation. So this is the energy balance equation for unsteady flow processes. correct? Please pause this video and spend 2 minutes to simplify this process for actually this equation for this specific process. Okay, now let's simplify this equation. So qnet, you need to keep the qnet. We are looking for qnet. This is the unknown parameter. What's about the WNet? To answer this question, is there any shaft cross the boundaries, or is there any electrical work? No, there is nothing for this. So you can simply cancel the WNet. Sigma m theta in. Is there any inlet in this case? No, there is no inlet, so you can cancel this one. So we have the exit. You need to keep m theta out, and then also m2 e2 m1 e1. So you can simplify the energy balance equation into this equation. So if you remember, guys, theta is a combination of enthalpy, kinetic energy, and potential energy, and E is a combination of internal energy, kinetic energy, and potential energy. In this case, we can simply assume that the kinetic energy and potential energy of this system is constant. So you can cancel delta kinetic energy and delta potential energy, and then you can simply write qnet minus MEHE equals to the M2 U2 minus M1 U1 of the system. So we are looking for the qnet, correct? What you need to do, you need to find ME, HE, M2 is known, U2 and U1. So you need to find ME, U2 and U1 for this, process. Now, please spend 5 minutes. Please pause this video. Spend 5 minutes. You have some information for the state 1, state 2. Please spend 5 minutes and then find ME, HE, U2, and U1. Okay. To find the ME, you need to write the mass balance equation for unsteady flow processes. So this is the equation, mass balance for unsteady flow processes. So M2 is known, M1 is known, Mi is 0. There is no inlet, so you can just simply find Me because M1 and M2 are known. So this is the Me. You found the Me. To find the HE, U1 and U2, correct? For this part, to find the U1, you have the T1. T1 is known, it's 26 centigrade. It's a saturated mixture, correct? So for the saturated mixture, it's a saturated liquid, saturated vapor. To find the U, you need to have the quality, correct? Remember, U for the saturated mixture equals to the UF plus XUF G. You can find UF and UFG from the reference table because you know the temperature, but X quality is unknown. First, you need to find the quality. How you can find the quality? To find the quality, guys, you have volume and you have the M1. You can find the new one, correct? You can find the new one. Now you have the new one, and you know that the new one equals to the new F plus X new F G. From here, you can find first X, and then by having the X, you can find U. Okay, here you can see, the details. So you have the new FG, new F, and then you can find the X, X1 quality is point 06499, and then you can find UF, UFG from the table A1, and then you can find the U1. This is the U1. Now, you need to find the U2. How you can find the U2? To find the U2, you have actually, you can repeat this procedure. You have the volume. The volume is constant. You have the M2, so you can find the new 2. New 2 is known, and then you can find the X2, correct? So look, guys, X, yeah. So, okay. Now, And then from here you have the UF, UFG, and by having the X you can find the U2. Okay, now the last part, to solve this question you also need to find the HE, correct? So for the HE, sorry, this is a typo, I should, correct it. So for the HE, according to the available information, only saturated vapor at 26 degrees centigrade leaves the control volume, meaning that the enthalpy for the, flow that leaves the control volume equals to the enthalpy of saturated vapor at 26 centigrade. So you need to report HG. Now you have the U1, U2, HE, ME. You can substitute into the energy balance equation to find the Q net. And Q net is positive, so this is actually Q in. So look guys, this is the step-by-step process to solve this problem. I have another problem. We'll go over this problem. So I provide a guided note for you guys, and so we will go over that file. Okay. Uh, so okay, now this is the, please open the PDF file available on the Blackboard. Here there is again, there is a tank. Keep in your mind that this is an insulated tank. What does that mean, insulated? When you have insulated tank, QNet is 0. So you can just simply write QNet is 0. Then you have some other information. I prepared, this table, but please spend 2 minutes and complete this table. Add all information to this table, and then we can go over, the other part of this problem. Okay, now as step 2, you need to answer this question: is it a steady flow process or an unsteady flow process? This is really important. Why? Because we have two different equations for steady flow processes and unsteady flow processes. So again, this is a tank during discharging process, and so this is on a steady state, process. So what you need to do, you need to set mass and energy balance equation for this process. I add, mass and energy balance equations. Please spend 5 minutes and then simplify mass and energy balance equations for these two, actually for this process. Okay guys, so the mass balance equation will be the same as the previous example. There is no inlet, so you can cancel Mi. So then ME equals to the M1 minus M2. This is the mass balance. For the energy balance equation, so to simplify the energy balance equation, yeah, this is the energy balance equation for unsteady flow processes. So Q net is 0. Why? Because this is an insulated, rigid tank. So you can simply cancel the Q net. What's the W net? So this is actually unknown parameter. You're looking for the electrical work. So you need to keep this W net. And then there is no inlet. You can cancel this term. And then again, we'll reach to this equation. Again, guys, you can assume that the kinetic energy, changes in kinetic energy and potential energies are negligible. And then you can cancel those terms. And this is the equation, guys. I just simplified the W net. W net is W out minus W in. And then W out is 0. We have the W in. And so this is the equation, guys. To solve this problem, you need to find M1, M2, ME, HE, U2, and U1. Look, guys, all these parameters are unknown. You have nothing. So please spend 5 minutes and then try to find, all these unknown parameters. I just wrote those, unknown parameters in the back side of your guided notes. Spend 5 minutes and then find, the unknown parameters in this part. Okay, now to find the M1 and M2, you can assume that this is, ideal gas. You have volume, you have pressure, temperature. You can use ideal gas equation to find M1 and M2. So this is the M1 and M2. To find the ME, you can use the mass balance equation to find the ME. Correct. So the ME is the difference between the M1 and M2 of system. Now you found M1, M2, and ME. The next part you need to find U1, U2, and HE. So keep in your mind that you have the temperature. Correct. The temperature is called, it's 580 Rankine. So you have the temperature. You can use table A17, I think. Yeah, A17E to find the properties of air, as you know, ideal gas. So you can find the T1, actually this is the TE but not the TI, guys. This is a typo. So the TE, you have the HE, T1, T2, U1, and U2. Look, guys, temperature is constant. Correct. So U1 equals to the U2 because internal energy depends on the temperature, but the right side is not zero. Craig, this is a mistake, guys. Don't just put this right side as zero. No, this is not zero. Yeah, U1 equals to the U2, but M1 is not the same as the M2. Correct. So if you substitute all this information, ME, HE, internal energy, M1 and M2 into this equation, you can find the WE. So this is, the on a steady flow processes. Please study following example from a textbook 5.1 through 5.13. They are really useful, examples, and I will be in touch with you guys for the next week, presentation and also exam. Thank you so much and have a great day.